Okay, we're now going to look at a question on integration where we have a partial fraction, or we have to use a partial fractions method in order to solve the integration question. And this follows on from the previous movie about integration using the partial fractions method. So I'll write down the question, and then what I suggest you do, if you want to try it yourself, is to pause the movie and try the question yourself. Remember, I've given you a big hint that it's a partial fractions question, and then see if you get the same answer once you continue playing the film. So here is the question. I want to integrate x plus 1 over x squared minus 7x plus 10 dx. Okay, so that is the question that we want to solve for. And so at this point I would suggest you pause and try the question yourself. Okay, now for the solution. First thing you need to do is you need to factorize the bottom. Now you can, if you watch the other movie where I actually described the method, I forgot about the integration signs and just dealt with the fraction inside and then put the integration signs in at the end. However, you can still use the integration signs as long as you are correct each time. So this integral is equal to the integral of x plus 1 over some two factors which multiplied give us x squared minus 7x plus 10. So obviously we're going to have an x here and an x here. Seeing as we have a plus 10 and a minus 7x, these are both going to be minus. So two things that multiply to give 10 and adds to give 7, so that's 5 and 2. So x minus 5 and x minus 2. Okay, so we've successfully factorized the bottom. Now we want to write the integrand, the thing on the inside, as a sum of two fractions with the denominators x minus 5 in one and x minus 2 in the other. So the integral would then become a1 over x minus 2 plus a2 over x minus 5 dx. So now we must solve for a1 and a2. So obviously a1 times x minus 5 plus a2 times x minus 2 has got to equal x plus 1. Now remember, how did I get this equation? Well, if we were to add these two fractions together, that's that one and that one, the LCM of the bottom is x squared minus 7x plus 10. And so when you add these two together, you would do a1 times x minus 5 and a2 times x minus 2, and that must equal the numerator we had at the beginning, which is x plus 1. So as before, I use a slightly different cover-up method where we want to cancel each one of these brackets one at a time. So if x is equal to 5, then the first bracket is 0, so we're left with a2, 5 minus 2 is equal to, now here students often forget to plug this x equal 5 into the right hand side as well, because there is an x there. So it's equal to 5 plus 1. So what's that? That's 3a2 equal to 6, therefore a2 is equal to 2. So we've solved for a2. And let's make the other bracket 0, so if x is equal to 2, we've got a1, 2 minus 5 is equal to 2 plus 1, so that's minus 3a1 is equal to 3, therefore a1 is equal to minus 1. Okay? Now, as I'm able to do here, I'm just going to rub up my a1 and a2 and write in those two numbers so that you can see where the integration question is going. So a1 is minus 1, so that's a minus 1 there, and a2 is 2, so that's a 2 there. So the integral of x plus 1 over x squared minus 7x plus 10 is equal to the integral of these two simple fractions. And seeing as the denominators are linear, we can now deal with that. So let me just write down the integration question again with these new linear fractions. There's 2 x plus 5, sorry, that's x minus 5, slight mistake there, x minus 5 dx minus the integral of 1 over x minus 2 dx. So remember, when you have a sum, the integral of each term is equal to the integral of the whole thing. So that's 2 ln x minus 5 minus ln x minus 2 plus a constant. Okay. Now you could add each constant. You could add a constant for each of these integrals, but it's effectively the same thing as adding a constant at the end, because you can add the constants together. Okay, so we can simplify slightly. This would be correct, but we can simplify slightly. This is equal to the ln of x minus 5 squared minus ln x minus 2 plus c, which is equal to ln, remember as we're taking away two log terms, the inside is divided, so it's x minus 5 squared over x minus 2 in the modulus sign plus c. And that's your answer. Okay? So, when we do such questions, make sure when you're doing the partial fractions, so let's go back a bit, that you work through all of this slowly and correctly, and don't forget, as students often do, to make sure that you also plug the x when you're choosing specific values of x to the right hand side as well. Okay.